This lecture is for Biostatistics NW395N, and we will cover non-parametric tests today, and your instructor is Dr. Marge Benham-Hutchins. So this presentation will be covering non-parametric statistic. It will be based on the readings from Kim and Mallory textbook on non-parametric tests and categorical data analysis, and also on the Cronk book, Chapter 8, Non-Parametric Inferential Statistics. I'm going to follow the order that Cronk presents the tests because I think it's a little bit clearer than what is in the textbook. So we will talk about chi-square and some of the associated tests such as goodness of fit, test of independence, Fisher's exact test, Phi and Kramer's V, the Mann-Whitney U test, Wilcoxon test, Kruskal-Wallis H test, Friedman's ANOVA, and then a little bit about relative risk and odds ratio. The learning objectives for this lecture are to help you distinguish between the parametric tests that we've been studying already and the non-parametric tests. Evaluate the assumptions of the non-parametric tests of differences, and this helps you know when you will be using the appropriate test. And again, we're going to visit the independent sample and dependent sample types of tests, and then to help you distinguish between two samples and more than two samples, and what type of test you would use for that particular data set. So far we have been studying parametric tests, and we have learned that they have assumptions of such as normality, and that when these assumptions are violated, we can't trust the results. So non-parametric tests are alternatives to use when assumptions are violated. For example, we might be interested in investigating the relationship between two categorical variables. One may be blood type and the other would be response level to treatment, such as recovery, disability, or death. Pearson's R, Spearman's Rho are not appropriate due to the level of measurements, and so we would want to be able to find a non-parametric test that we could use to study this data. I also want to point out to you that there are some differences in the way these non-parametric tests are approached by Cronk and by the authors of the Kim and Mallory text. The Cronk book is very up to date and provides you information on the new SPSS modeling procedures that are available for versions 18 or above. And this means that you can actually run a few tests at the same time. And so I'm going to mention all the different components that you will need to do for these tests. But when you're running your tests, your practice tests using SPSS and following Cronk, notice that there's times when the post hoc analyses are actually something that you can plan for ahead, and so you don't actually have to go in later and do it. So this will make more sense, and I'll mention this some more as we move forward, but I wanted to make sure that you realize that the Cronk book is using the more modern or newer features than SPSS, while the other book is actually using a different way to do a chi-square test and some of the other statistical analyses. So I recommend that you stick with the Cronk book since we have a very updated version of SPSS that we're working with. The chi-square test is a type of non-parametric test that is used to test the relationship between two categorical variables. So similar to the last slide, we have other questions that can be addressed using this type of statistic. For example, is there an association between disease and a factor? Is there a difference on prevalence between two hospitals according to gender? Is smoking, yes versus no, related to whether a person drinks coffee or not? Is satisfaction level related to types of health insurance coverage? So these are some of the types of questions that you may want to look at. So the chi-square goodness of fit test determines whether or not the sample proportions match your theoretical values. So this would be similar to looking at the proportion of children born with birth defects to the population value. So you may want to determine if a certain neighborhood has higher than normal rates of birth defects. The chi-square test of independence tests whether or not two variables are independent of each other. For example, coin flips are independent events, so knowing the outcome of one should not tell us anything about the second coin toss. So the chi-square test does have some assumptions, and that is that all the observations are independent, and the expected count in all cells should be greater than 1, and no more than 20% of cells should be less than 5. The hypotheses are, the null hypothesis is that there is no association between two categorical variables, and the alternative hypothesis is that there is an association between two categorical variables. So the chi-square test can only tell us whether the variables are related. The phi and the Kramer's V test can be requested when you're running the analysis to examine the strength of the relationship. Phi is when you have a 2 by 2 table, and Kramer's V is for the contingency table that is larger than 2 by 2. So you evaluate your chi-square very similar to when you looked at correlations. As the coefficient approaches 0, the association between the two categorical variables is weak, and it is large as the statistic approaches 1. And also the negative and positive signs will indicate whether the association is a positive or negative relationship. There is another non-parametric test called the Fisher's exact test. And this is if you would be violating the assumption of the chi-square test that the count in all the cells is greater than 1 and no more than 20% of the cells should be less than 5. If this is the situation and you have a 2 by 2 contingency table, then the Fisher's exact test would be what you would be used instead of the chi-square. I've provided a reference here from Wikipedia. When I went on while I was working on this presentation, I looked at the Wikipedia site for the Fisher's exact test. I felt like it had good content to get started, and it has multiple references on this test. And so it's something as a kind of a jumping off point to have you learn more if you find that you're going to be running a Fisher's exact test and you want to have some more information on it. The Mann-Whitney U test is the one that you will use when the assumptions are not met for an independent samples t-test. In other words, it's the non-parametric equivalent of the independent samples t-test, but it's weaker. The assumptions are that you'll have a random sample, that there is independence, two groups are independent of each other, and the level of measurement is least ordinal. The hypotheses are for the null hypothesis is the distribution of X is the same across categories of Y, and the alternative hypothesis is the distribution of X is different across categories of Y. This is one of the tests that you'll have an opportunity to do hands-on in the Cronk book, and you'll be using some of the new features that are available in SPSS to help you run these tests. The Wilcoxon test, sometimes called the Wilcoxon rank sum test, is the non-parametric equivalent of the paired samples dependent t-test. The assumptions here are that the sample is a random sample of the prospective population, variable measurement is continuous, and the level of measurement is at least interval. The hypothesis the null hypothesis is the medium of the difference between the measurements is equal to 0, and the alternative hypothesis is the medium of the difference between measurements is not equal to 0. So this is another one that you are going to have an opportunity to run, do some hands-on in the Cronk book and use some of the new features in SPSS that I think you're going to find very helpful. So this is the Kruskal-Wallis H test, and this test is the non-parametric equivalent of the one-way ANOVA, and it tests whether or not several independent samples come from the same population. The assumptions for this test are that all samples are random samples from their respective populations. 3 or more samples are independent of each other. And the level of measurement is, for the dependent variable is ordinal, and the independent variable is nominal or ordinal. So when you're interpreting this test, it's important to recognize that when the p-value is less than your chosen alpha, the group means are said to be different. But this only indicates that at least 2 group means are differ, but not which group means differ. So post hoc tests are needed. And so that's one of the things that's nice about the real language model viewer in the newer versions of SPSS, that allows you to select multiple comparisons and all pairwise to compute the post hoc test while you're running the test. And so this is something that you'll be able to do hands-on in the Cronk book, but I think you'll also really like the type of output and information it gives you. And for this particular test, when the p-value is greater than your chosen alpha, then the group means are said to be the same. The Friedman test is the non-parametric equivalent of a one-way repeated measures ANOVA. This is used when you have more than 2 measures from related participants and you don't meet the assumptions of the repeated measures ANOVA. So the assumptions for the Friedman tests are pretty simple, and that is that because it uses ranking of variables, data must be at the ordinal level. This is another test that I found some good information on Wikipedia as a jumping off place, a place to start, had some good references. So if you are faced with using this test, I recommend that you do a little bit more homework and learn more about this particular type of analysis before you begin. I want to touch briefly on relative risk and odds ratio. These are 2 common measures of effect size. So relative risk is defined as the measure of the risk of an outcome occurring when exposed to a risk factor. This is commonly used in cohort studies, longitudinal analysis of risk factors, or randomized controlled trials. Odds ratio is defined as the ratio of an outcome occurring when exposed to a risk factor. The odds ratio is commonly used for case control studies in which non-condition and condition groups are compared to identify factors that may contribute to an outcome. These are things that we see, these tests we see relatively often in healthcare. So this slide provides an overview of how you would calculate relative risk and the odds ratio. There is a descriptive table provided with information on smokers and non-smokers with lung cancer or without lung cancer. And then there are equations below that show you how you would calculate the relative risk or the odds ratio. So the relative risk is calculated based on an outcome occurring when exposed or an outcome occurring when not exposed. So if you look at the calculation below, it's 86 divided by 134 over 23 divided by 94. So you're looking at the smokers and dividing by the total of smokers, and then you're looking at the non-smokers and divided by the total, and then you come out with a calculation that is your relative risk. The calculation for the odds ratio is different. It's the odds of an outcome occurring when exposed to a risk factor over the odds of an outcome occurring when not exposed to a risk factor. So here you're going to divide the number of smokers with lung cancer divided by the ones that don't have lung cancer, and then you will divide that by the non-smokers that are calculated as the non-smokers with lung cancer divided by the non-smokers without lung cancer, and then you will come up with your odds ratio. So when you're interpreting the relative risk and odds ratio results, if it is equal to 1, it implies that the risk or odds of the 2 groups are the same in terms of an outcome occurring. When it's greater than 1, it means that there is a positive association between the outcome occurring and an exposure to a risk factor. And an exposure to a risk factor will increase the occurrence of an outcome. And if it's less than 1, there's a negative association between the outcome and an exposure to the risk factor. So, for instance, for this last one, if it was a negative association, would be that people that smoked were less likely to get cancer. So, an example reporting would be that, as indicated here, odds ratio was computed and indicates that the odds of getting lung cancer were 5.53 times higher for a smoking person than a non-smoking person. And if you go back to the previous slide, you'll see where the 5.53 was calculated. So we covered a lot of content in this particular presentation, and there are many different non-parametric tests, as you have and you have learned about some of them here, and you'll have an opportunity to do some hands-on work with them in the Cronk workbook. It's important that you're familiar with the different tests, and that if you are looking for the correct statistical test to run on your data, that you're able to consider these along with the parametric tests. If you have questions about this presentation, please post them in the frequently asked question area. And as I've mentioned before, if you're really uncomfortable doing that, please email them to me. And if it's a class-related question, I am happy to go ahead and post it there for you, or I may just ask you to post it with the answer. This helps everybody. And if you have questions, please don't hesitate, because this really helps me to know whether or not your students are getting the content, which is always a challenge in an online class when I can't see your faces and I can't always tell for sure how people are doing it, if this type of complex content is sinking in. And like I've said repeatedly, this is something that, you know, for this test, you're going to have, for this class, you're going to have open book quizzes and tests. The final test will be a comprehensive that'll cover the content of the whole semester, but you have access to the PowerPoint, you have access to your books and a lot of different resources. And to me, that's the real important thing, is that you recognize what it is you need to find and you're able to find the information that you need. I appreciate your attention, and once again, please don't hesitate to post any questions.